Okay, if nobody has any questions, I'll move on to the TechGen integration. So just to give you a very brief overview of some of the capabilities, on the left-hand side, there's a screenshot directly from the tutorial where we've written a couple of examples for generating a domain in TechGen, as well as then we've written some wrappers inside PuMapy, a couple of functions to export the data structures from TechGen to a voxel grid, which can then be re-imported inside PuMapy, basically making them understandable by PuMapy. So a couple of examples of woven microstructures that we're able to generate are the layer-to-layer weave on the left, and on the right instead is another type of weave that is of interest to NASA. So next, after this, I'm going to play the video about the TechGen integration, and there will be two videos, one about running TechGen inside on a Mac, and it's the same on Linux, and the other one will be how to use the TechGen GUI in Windows and export some weaves from the GUI and re-import them inside PuMapy. So I'll play the next section. Okay, in this section I'm gonna discuss about a very capable C++ library called TechGen. This library was integrated inside PuMA, and it is able to generate microstructures like the one shown here for basically artificial weaves. So the nice feature about wrapping TechGen inside PuMA is that now the user has access to it directly by just running the conda install command. However, the installation varies between Unix and Windows. On Unix, conda install installs every component of PuMA, including TechGen, whereas on Windows, conda install only installs PuMapy without TechGen. However, in the second part of this video tutorial, I'm gonna show you how to still use TechGen, and actually the nice feature of Windows is that we can generate microstructures inside the TechGen GUI and then export them and re-import them into PuMapy. So for this section of the tutorial, I will focus on a Python script to basically call TechGen and generate a weave and then import it inside PuMapy. And the specific tutorial that I'm giving comes from this website that explains the use of TechGen. And then there is also another resource that I want to point you to is on this GitHub page, which is about already made Python scripts, which you can modify for TechGen directly. In this case, I'm gonna run the layer-to-layer text style. So in this case, here is our Python project inside PyCharm that we've been running so far. In this case, I just basically copied and pasted the layer-to-layer weave, and then the interface that we implemented inside PuMapy is basically these two functions to export the weave from the TechGen data structure and to re-import it inside PuMapy so that it's in a voxel grid that PuMapy can interpret. So I'm gonna go ahead and run the script, and you will see a lot of output from the first part of the weave generation. So it's basically building toe by toe, and then you will see how it will export it and re-import it inside PuMapy and volume render it. Okay, the generation is completed, and here you see the volume rendering of the weave that has been generated. A small thing to notice is that the only thing that you can control in a weave is the largest dimension for the voxel grid. So in this case, I basically selected 200 voxels in the longest x-axis, and then the other two dimensions are driven by how your weave looks, by the way that you basically code it up in TechGen, in the TechGen Python script. This is the end of the Mac part tutorial. I will now switch to Windows. Okay, change of scenery here. I'm currently running on my Windows machine now, and I'm gonna first show very briefly how to install PuMA, or pumapy actually, because we're on Windows, on Windows. First, I assume that everybody has installed Anaconda on their Windows machines, and so now we're gonna be able to create the Conda environment, and I'll call it again PuMA tutorial, and I'll also install pip inside this environment. So once this completes, I'm gonna go ahead and pip install PuMA, actually pumapy, and so the creation is completed. So I'll go ahead and say conda activate pum_ tutorial, and then pip install pumapy. It's gonna install all the dependencies as it does for conda install. And so once this is completed, we're gonna be able to run pumapy on Windows. And then at that point, I'm also gonna show you very briefly how to create a PyCharm project, which actually I can show you while that is running. Okay, the pip install is already complete. So I'll go ahead and create a new project, and I'll just go and call it again PuMA tutorial. And then for the interpreter, I need to go and pick the one that I've just created inside the environment. So in here, it's probably not going to showing. So in here, I need to go into Anaconda, and PuMA tutorial, PuMA Python X. Okay. Create. So this main.py is gonna be auto-generated. At this point, I've also created a small Python script that we can run. We'll paste it in here. And so let me first check that PuMA is running. All right. So this warning is normal, and it's just saying that TechGen is not found, and it's because we're running on Windows. So that's to be expected. So this small script that I created basically just is gonna help us deal with the GUI, and basically let us automatically export a weave from the GUI, the TechGen GUI, and import it inside pumapy. So now I'm gonna open the TechGen GUI, which I'd already pre-installed. I'll go ahead and generate a similar layer-to-layer weave as I did for the Python script on the Mac. So I'll give it 4 layers so that it will look similar to the one that I had. And so I'll go next, and I'll just make it a little more interesting so that it has some weaviness in it, and then I'll accept. Once that is generated, you will see here in the TechGen output, it has been generated. So now the way that I'm gonna be able to export this from the GUI is by basically going here inside export, and then inside voxel mesh. However, what we need to figure out first is how many voxels we want in each dimension, because that TechGen doesn't do that for you automatically, and that's where the Python script that I had created is gonna come handy. So the way that I'm gonna do this is basically by plugging in the largest dimension that I want. In this case is 200, and then first I need to comment this last few lines, and then I'm gonna basically need to fill in the dimensions that are shown here in the 3D rendering. So for the X dimension, for example, here it goes from 0 to 4, as I had already filled in. In the Y dimension is 0 to 2.5, and in the Z, okay, it's exactly the same. So I will press run for this one. This will give us the 3 dimensions that I need to plug in here. So it would be 200 and 125 for the Y and 41 for the Z. And then at this point I'm going to output it so that it's called as it's suggested by this script, the file name with test, and then you need to put basically the 3 dimensions. Save. Once this is successfully exported, I will be able to plug it inside, re-import it inside PuMA using the wrapper functions that I mentioned earlier. So it looks like, yeah, so it looks like it's now completed. And now I will import it and render the volume. It's also important to change the voxel size, which is one of the parameters that you can set inside the workspace. And as you can see, it is now being imported, and our voxel grid looks very nice. So this concludes the part about the integration between PuMapy and TechGen.